All right, so we got the last lesson in logarithms, actually. Then we're going to switch over to something else. But this is money today. But first, we're going to do something old. Let's take a walk down logarithms here. You can use log is bay to solve this one. This is an exponential. And it's not a hard one if you've just figured out how to do the easy stuff. 7 minus 4 is 3. We have 3 equals 3.2 to the 3t power. Now, there are a lot of kids who think you can divide both sides by 3.2. You cannot do that. I don't know why they think they can do that, but that's what they do. You have a base, you have an exponent, and you have an argument. So you're going to make her a logarithm. She would become a logarithm of base 3.2. Her argument is 3. By the way, this says what power of 3.2 equals 3. You and I don't know that, so we're going to have to use technology to some degree. And then that would equal 3t. Now, to isolate t, you're going to have to divide by 3. So this is the answer, but you got to know how to actually come up with a numerical answer, no doubt. So you need to be using change of base. So log base b, argument a, is, and I'm an ln person, is the natural log of a over the natural log of b. So I'm going to rewrite this as the natural log of 3 over the natural log of 3.2. Now this 3 stays in the denominator. Or, you can write it like this, and it just looks really ugly. It doesn't really matter which way you do it, but one of them looks prettier than the other. So anyways, what did I have? And the natural log of 3 over, let's do this a safe way, math, num n over d. I had the natural log of 3, sitting pretty over 3 natural logs of 3.2. There we go, 0.3148. If you go 4 digits, it's about 0.3148. Easy peasy lemon squeezy. All right, so that's all about money today, just going over money again. If $2,000 is invested in an account that pays 11.9% interest and compounds semi-annually, what will the investment be worth in 10 years? So because of how they talk about compounding, I know that the formula is the formula for compound interest, which is the principal times 1 plus the rate of interest over the number of times that the interest is compounded per year, raised to the nt. Now, we have semi-annually. That happens twice a year. Semi means 2. It means half. So every half a year. The principal is 2,000, and I want it to be in 10 years. So the amount in 10 years is a principal of $2,000 times 1 plus the rate, 0.119, sitting pretty over 2 again because n was 2 from just a few seconds ago. Raise the 2 times 10. And this is one of those problems that you shouldn't miss, but a lot of kids will because you just don't care. Let's be real. You just don't care. And you know that. So, take the course again. Maybe you'll care next year. You get $6,354.03. Easy peasy, if you want to do it. All right, Bob invests $2,000 into a savings account that pays 3.95% interest compounded daily. How long will it take for the investment to double? So again, you just write down your formulas and you think about where things need to go. He's got 2,000, that'd be your principal. Rate 0.0395. Don't you be the kid that can't do that. Daily, 365 days in a year. So there's another n. And the question is how long? T is unknown. And it's going to double, so it's going to become $4,000. Now we're going to do this one by hand. We are not y1ing, y2ing this thing. You're supposed to learn your logarithms. We're going to go ahead and divide out that $2,000. It's going to give us a 2. Big surprise there, right? All right, let's see what's in this set of parentheses. We've got 1 plus 0.0395 sitting pretty over 365. Probably can't make that a fraction. A person could. It'd take them a few minutes, but like I could make that a nice fraction, but your calculator can't. Crazy, huh? So we have a pretty ugly number here. We got 3 zeros, and we'll just say 108. Now I'll keep using this number in the calculator. I will. We got 1.0000108. It's raised to the 365 t power. All right. Now, I'm going to do the ln both sides technique. So I left a gap there. As long as you do the same thing to both sides, you're fair. When you do the ln both sides technique, you get to remember the rule about logarithms, that exponents of logarithms get shifted out front. They become factors. They tell you how many times logarithm actually happened. So now the natural log of 2 is 365 t natural logs of 1.000108. Now, there are two things attached to this t, and they're both attached through multiplication. And the opposite of multiplication has always been division, and it always will be. It's not going to change one day and decide to become subtraction. It can't do that. So we divide both sides by 365 natural logs of 1.00018. 108. And that is my answer. Now, I actually push the buttons. Notice I'm going old school here, so I'm doing like a master wrap on the parentheses. What I'm going to do is I'm going to highlight that number right there. Keep every bit of it. We got 17.55. We'll say 17.5 years. Easy peasy lemon squeezy. All right, Mandy invests an unspecified amount into an account that pays 7.9% compounded quarterly. How long will it take for investment to triple? So I'm just going to invest $1. You have to make something up. The smaller you make it, the easier the numbers. We're still plugging into the formula for compound interest because we can read and interpret text. But this dollar becomes 3.079 because we know how to shift a decimal 2 places to the left. And it is invested quarterly, so n is 4. And I don't know the time, so it's just a 4t. And this is a lot like the last problem was, isn't it? It looks like the same thing. But this ought to be a much better looking fraction. It ought to have an end. 1 plus 0.079. Sitting pretty over 4. Yeah, it stops at 5 digits. So 1.01975. It's raised to the 4t. And I didn't have to do any division on this one because there was a 1 attached to that set of parentheses. And this time, just because for good practice, let's make this thing a logarithm. We have a base, we have an exponent, and we have an argument. So we have a log whose base is 1.01975. Our argument is 3. This, by the way, says what power of 1.01975 is 3? And it would equal 4t. Divide both sides by 4, and then you'll be in a mood to push buttons after you do change of base formula. No. And that's the thing. That is going to get so many kids. They're going to get this far, and then they're just not going to know what to do. Again, I'm an ln guy. I'm going to rewrite this as the natural log of 3, sitting pretty over the natural log of 1.01975. And I already had a 4 down low, so we're just going to put it right there. And that's my t-value. So let's see what we have here. Math, num, n over d. Natural log 3, sitting pretty over 4 natural logs, 1.01975. 14.04 years. Almost done. You'll notice this question has a keyword of continuously. Chuck has $400 to invest. If an account pays 5.8% interest and compounds continuously which according to your form quizzes, 3 out of 4 of you still don't know what that formula is. When will this account be worth $2,000? Those formula quizzes are given to you every single day to help you out. That's why I'm doing it. I've got 400 bucks. That's my principal. There's an E, which is just a number. R 0.058. You can figure that out. God bless you. I don't know the time, but it's going to become $2,000. There you go. That's a setup. Divide 400, and you're actually trying to figure out when his investment quintuples. Quintuples means fivefold. And this thing is one of the easiest things in the world to become a logarithm, isn't it? I feel like it is. Base, exponent, argument. She's a log whose base is e. Her argument is 5, and she equals 0.058t. Now, a log base e is always called a natural log. It's Euler's log. A natural log of 5 is 0.058t. Divide both sides by 0.058, and you'll be in shape. Natural log of 5, sitting pretty over, 0.058, 27.75 years. I think that's what my TI-84 said. Yep, 27.75 years. Or 27 years and 9 months, maybe. All right, your financial investor swears he can triple your investment of 600 bucks in 8 years. You should really throw more than $600 at this. What will the annual rate of interest be? So use the amount after time as the principal times 1 plus r to the t, or the amount after time as the principal times 1 plus r over n to the t. But if we just this guy, n would just be 1. Because it only happens once per year, because I want the annual rate of interest. But for the next two, it might make sense to use the other one. So for the yearly, I'm going to use this one. And of course, there's other shortcuts to getting through this, but actually, no, we're just going to delete this from the notes. That doesn't need to be there. Anyways, where was I? We're going to triple 600 bucks, so it's going to become $1,800. I have no idea what the rate of interest is, but the exponent here is 8. See, this isn't even a logarithm problem. We're going to get a 3 when we divide out the 600. The opposite of the 8th power is the 8th root, affectionately written as the 1/8 power. Shame you don't know that. We're going to subtract 1 from both sides. And then we'll go push some buttons and we'll see what that rate is. (14.72% per year). Pretty awesome. Now, when you talk about the monthly rate, the easiest way to do this is to realize that 8 years is 12 months in a year. 12 times 8, 96 months. So the same setup, but instead of having a 8 as an exponent, you have a 96. And everything else is going to be the same too. You're going to have your 3. Your 1 plus r is now 96. And instead of the 8th root, you're taking the 96th root. You're still going to subtract 1. And I should say 1 over 96, sorry. And that looks really bad, doesn't it? Down here at the bottom of the page. We have 3 to the 196th power, and that would be equal to 1 plus r. We're just going to subtract that 1. And then we're going to see what it generates. And this would be the monthly interest rate. And you can see it's about 11.51%. And if you want the daily rate, well, the math's a little harder on that one. You got to figure out how many days are in 8 years. We should probably add 2 for leap years, but, whatever. 2,920 days. So, same setup. And, we should be able to jump down to here. We're going to do 3 to the 1 over 2,920, 1 plus r. And then we should be able to push the buttons and get this thing going. Oh, scientific notation, 3.7631 times 10 to the negative fourth power. Okay, let's talk about that. Let's move that decimal 4 left, include the leading 0. So 3 zeros in front of that 3. That's what she looks like as a decimal. Shift it 2 more places to the right. Let's round it. 0.038% per day. All right, last one's coming up. An investment will compound interest continuously. There's that keyword, continuously. The amount after time passes is PERT. Over the course of 10 years, there's your time, and quintuple. That means times 5, the initial amount invested. So we're going to invest $1. It's going to become 5. We have an E. We don't know R. We know that the power is, that the time is 10. Let me say it that way. So look at this thing. This thing is just begging you. It's screaming at you, make me a logarithm. Like that's legit what it's saying. Base, exponent, argument. A log base E argument 5 is 10R, which is known as the natural log. We'll divide by 10 and we'll be done. So simple. So simple. There you go. 0.1609, 16.09%. And that's it. That's the end of logs, actually. We'll do a little bit more with them, but the actual instruction on logs is done. It was supposed to be done last Friday. I got behind.